All right, so if you remember, this is over parts 4 and 5. So if you turn to page 76, I kind of want to remind you of the things that you need to know how to do to be successful on the quiz. You know, we're not necessarily going to go over all of it, but remember that you want to do a particular value with a particular frequency. It's one variable stats of list 1 with list 2's frequency. That gives you the expected value and the standard deviation. What's another name for expected value? The mean. Okay, so remember that another name for the expected value is the mean. All right, if you go to page 77, I also want to make sure that you know how to do problems that you will have a problem about the probability of at least one. So probability of at least one, listing all the combinations is not fun. See, in this case, when we had probability of at least 1, 6 in a pair of die, you could list out all of the possible combinations and add those up. But it's easier with 1 minus the probability of none. So in this case, we could do our little 1 minus the probability of neither of those dice, 2 dice tosses, are 6s. I mean, because they're independent events, you're going to have not a 6, and, so that one's not a 6, and this one is not a 6. So they are both not 6s. 1 minus that is another way to get the answer instead of doing all the possibilities. Okay, questions on those so far? All right. Now, another thing that I want to remind you of is given that probabilities. So this is problem 25 on that section, which is maybe page 81. Okay, so if you go over to page 81, I want to give you another problem that I've made up here that's similar to this. So I want to remind you on your formula chart, which you will be given one of my laminated formula charts during your quiz. So I want to remind you that up here, is our given that formula. So we've got the probability of A given that B has occurred. And so that is that all of the B section, B probability, is on the bottom. And the numerator is the probability of A and B. It is not just probability of A. This is not probability of A over the probability of B. It's probability of B as the denominator, probability of A and B on the top. So let me show you a numerical example with that, one I just made up here by your number 25 on page 81. Suppose I say you got a big bag of dogs, of canines, okay? And 50% of the bag is puppies, 20% of the bag are labs, and 10% of the bag are lab puppies. So what if I ask you, what's the probability, given that you draw out a puppy, so I'm going to tell you, you draw out a puppy, what's the probability that it is a lab? Okay, so according to our little formula, what's going to go on the bottom is all the puppies. So there's 50% puppies in that. So out of the 50% puppies, what goes on top? Here, 0.1. On top has to be the lab and puppies, not just the labs overall. Okay. Well, in this case, they're independent, and so that 0.5 times 0.2 gave you 0.1, but you don't necessarily know if they're independent. But in this case, they are. And they gave you this. This was given to you. I did not figure that out on my own. Yes. Yes. They'll give you this because you don't necessarily know if you can just multiply or not, because you don't necessarily know if they're independent. If they are independent, then yes, you can just multiply. Okay?
If they don't necessarily take it and not use the that they provide you, how do you determine what you're talking about?
So sometimes they won't use the exact words given that, but they'll say something like, if you know that, you've already drawn out 2 kings and 2 queens, or let's see, upon drawing a puppy, what's the probability that it is a lab? You know, they can use other language words that would imply that that condition has to be met, and then that's a given that. Okay, so you just have to be careful with the language, but it's generally more obvious than the whole little pickle literature fiasco. Okay, all right, moving on. So now, in your second probability section, okay, so there's kind of an indication of 3 thoughts I've given you. Now, take a look at this formula chart. I want to remind you, you are going to have a question that kind of talks about, it's one of those 1 or 2, 1 and 2, 1 and 3, or whatever, and it relates to the formulas themselves. So make sure you understand, that this here is giving you the mean and the standard deviation for the number of items. This is what's giving you the mean and standard deviation for the sample proportions in the sampling distribution. Okay, these are in the sampling distribution. Okay, and then down here, this is the mean and standard deviation for the sampling distribution of sample means. And I hope you also know, your sample size requirements for normality. Let's make sure you understand what all these little things are. What is this N stand for? The number of trials, or the number in your sample. Okay? And then what is this K? The number of successes that you want. Yep. And then this P here is the probability of success. Okay? There are K successes, and then these ones over here is how many failures. So the failures plus the successes totals up to N. So again, the failures plus the successes totals up to N. Now let's talk Binomial Pdf versus Binomial Cdf. What kind of language would you be using if you want to do Binomial Pdf? They would be saying probability of finding what? Exactly 1 success out of 13, or exactly 8 successes out of 20, exactly 5, okay, whatever on that. Whereas Binomial Cdf, there's generally, you can either have, what's the probability that you get less than this many successes, more than this many successes, at least, or at most, okay? So those cumulative words for cumulative probabilities are greater than, less than, at least, at most, fewer than, those kinds of things, okay? All right, so I hope you remember how to do the binomials. It's not always 1 minus for the cumulative, not always 1 minus. So recall that if they ask you to accumulate, a good technique is to write down your sequence, and this one went up to 30, and they want x is greater than 1. See, I'm not real good keep these things in your brain kind of thing. I like the more concrete. I want to write it down and look at it and circle it. So I would, in this case, greater than 1 means that this is what I want. So I can clearly see that this is what I'm going to take off. So I'm going to do my 1 minus the accumulation up to 1, because I got to take off the 0 and the 1s. Okay, one more of these I want to talk to you about would be, say, in this case, fewer than 3. See, in this case, where you have 0 up to 23, you want fewer than 3, so that what you want is this part down here. Don't 1 minus. You just straight up accumulate 0 up to and including 2. All right. Okay. Now let me find a geometric. There will be geometric problem on there, such as this. So the geometric ones are when you say the first success occurs on the fourth trial. Okay, that's a geometric. The first success occurs on the fourth trial. Now, yesterday in the video, I did talk about two things. I'll say it one more time, just in case you didn't catch it or you have a question about. If you choose to not just calculate this by hand, by writing this kind of thing out, which I kind of like to do that, but if you want to use your calculator, or you're getting good enough at it that you are ready to jump to that level, geometric PDF, see in this case, I want to put the 37% on the fourth trial. That would mean I am putting the success exactly on the fourth and only the fourth. Okay? So this is not until the fourth. Now let's talk geometric CDF, if you're ready for it. If not, ignore it. Okay? So if you wanted to know what that thing in your calculator with the geometric CDF is, this would mean that they would be saying, what's the probability you get a success on or before the fourth trials? Do you see that? You're going to accumulate successes on the first trial, plus on the second trial, plus on the third trial, plus on the fourth trial. So I'm accumulating my successes on or before the fourth trial. Okay? All right, let's see. I think I've at least one. Binomial, geometric, the little one variable stats, formula. Seems like there's one more because there's 6 problems, but I can't think of what it is. So we'll just go with that. Okay, any questions that you have on any of those ones that I went over yesterday? Yes, ma'am. No, we will not be testing for independence. Okay? I need to talk to you guys about that before the AP test. That's kind of one of those little things I'll probably throw at the end right before we go do it. Right before the end. Okay? All right, so let's quiz parts 4 and 5 on probability.